We'll just get started. Thanks everyone for joining us on Monday afternoon. We have a very exciting next hour plan for everyone with experts to talk about both building foundation models, deploying it into applications, and also expertise in evaluating and providing governance around such applications. So we have an exciting hour plan. Just to get started, I'm the host and moderator today. I'm Jigar from Raga AI. We wanted to start by talking a little bit about Raga AI and what we are building at Raga AI. So let me talk about the firm. So Raga AI is actually a testing and evaluation platform for AI applications, especially focused on Gen AI. That includes things like testing and evaluation of large language models, also agentic applications, as well as RAG applications. Let me share my screen to give you a brief overview of what we are building at Raga AI. So I think everyone on the call today is pretty much aware of the potential of AI in general, and especially Gen AI, right? We have all seen like AI, like amazing strides made in the world of research and Gen AI development, including foundation models over the last couple of years. And what that has enabled is that it's enabled lots of applications that developers have come up with across the world, right? So the potential is enormous, but one big challenge that we see across every industry, and again, is really bridging the gap from POCs to production, being able to build safe, reliable, and cost-efficient applications that can work with good guarantees and assurance in a production environment. So this is what you have on your screen, right? Are some of the kind of concerns that we have all heard about. So things like on the reliability front, possible hallucinations, right? That is something that we are concerned about. Obviously, we have experienced it on a day, like in our own activities, well, whether it is using Hanuman or ChatGPT for that matter. Things like safety concerns. If you're building an application which is addressing things like healthcare, safety and bias detection, for example, becomes really, really crucial, because you might be causing unintended harm with the kind of AI application that you're rolling out into production. And the third thing is moving from your rule-based chatbots and other applications to Gen AI has been tremendous and successful, but it comes with costs. Every incremental percentage point of more performance improvement is a significant cost as we move to larger and larger models. So making sure that we are making the right business case possible in production is just as big a challenge. And Raga AI is designed to solve exactly this problem. Let me just walk you through our product with a video. So that's a very high level view of what we are developing at Raga AI. Just to do a deeper dive on that front, right? We offer users not just the capabilities to test and evaluate their LLM based applications, right? We also offer a playground at a agentic or a RAG level for people to quickly experiment and iterate. So testing and prototyping are things that can go hand in hand. Obviously, when we talk about evaluation, a big differentiator for Raga AI is real-time evaluation. That means cost and latency optimized evaluation, as well as the quality of our evaluation metrics on the platform. And finally, we also talked about cost and cost management. So enabling gateways which help users optimally route their applications in real time, managing cost versus quality is another big facet of the product, right? That we offer for the enterprise out of the box. So that's the Raga AI Catalyst product for you in a nutshell. But today we are actually also making a small version of this product available for public use. So we are very excited about that. That is the product you can actually visit yourself and try out at catalyst.raga.ai. Also, there's a lot of resources to go with it, from our documentation to user guide, as well as blogs. So these are resources that we'll be sharing with the group like during this webinar. So that's about Raga AI. Let me just jump in next to talk about and introduce our panelists for the conversation today. Yeah, that's great. So yeah, awesome. So welcome, Dr. Vishnu, Gaurav. It's great to have you both here. So just for the product group to provide I think most people joining us probably know about both Dr. Vishnu and Gaurav, but to provide a quick introduction, Dr. Vishnu is the CEO and founder of SML, the parent company behind Hanuman, as well as Busy, right? A leading healthcare AI firm. His work includes the development of Hanuman, as we know, multilingual, multimodal LLM foundation model that is used across different kinds of applications and industries. The big focus being supporting Indian languages. So again, the development of Hanuman represents like a significant milestone, not only in the global AI adoption, but also for India specifically. So very excited to have you here, Dr. Vishnu. And yeah, we also have Gaurav, who's the CEO and founder of Raga AI, where we talked about the AI testing platform previously. Gaurav has 15 years of experience leading AI and ML for leading firms like NVIDIA, Ola Electric, as well as Texas Instruments. So Gaurav has again worked on applications ranging from autonomous driving in the Bay Area to also ADAS in the world of mobility in India. So a lot of experience building products, building AI products, and now in the world of testing AI as well. So welcome, Gaurav.
Yeah, thank you.
Awesome. So with that, we'll jump into our webinar next. Just wanted to share some resources for our audience that joins in. So any questions that people might have, that we'll reserve a Q&A with the audience for the last 15 minutes of this hour. So please feel free to type in your questions into the chat. Our team of experts will be available to answer those as we go along. And we'll pick up a lot of questions for both Dr. Vishnu and Gaurav for over the last 15 minutes, right? So any thoughts or comments that you have, please feel free to share those with us as we go along. So yeah, that's really it. With that, we'll just jump right into hearing from both of the experts that we have here. First question is a simple one, a generic one, right? Dr. Vishnu, Gaurav, we would love to understand your journey and right in the world of AI, and why generative AI to you, like what road has led you to generative AI, and why it is the most exciting thing that to be working on today for you. Yeah, Dr. Vishnu, would love to start with you on that front.
Yeah. Before generative AI, my journey into tech also began very in an interesting way, because I'm a doctor, so I'm an orthopedic surgeon by training, and I have worked for many large healthcare organizations in India and worldwide. So I was in UN. So when we were in MIT, so I was a researcher there. Then I got some interesting idea on like how we can solve healthcare problems using machine learning. So, and big data, that's how I got interested in machine learning, did my MS, mostly focused on understanding ML. Then when we built Busy, works in a very futuristic part of healthcare, which is understanding the omics. Omics is understanding the genes and RNAs of the world, proteins of your body. So we generate a lot of data. So one data set I can say is nearly 250 to 500 GB of data we generate, and it's a very, very different sets of data. So when we started working on this, it used to take us weeks of bioinformaticians and computational biologists to crunch this data, make some sense out of it. And we said, this is never going to scale up. So it's so expensive also, these resources are so expensive. That's how I started looking into the AI modeling and stuff and seeing like, can we really understand this? And that's when we came across this transformer technology, and we saw that transformer can be, we can build models which can be understood by transformers. Then we can scale this up. That's how I started working with transformers for Visi. But when transformers became generative AI and then the whole world started talking about it, then we realized language has become technology now. Large language model means English. English has become technology rather than, earlier we used to build models. Now it's like English has become a model. But I said, okay, English is a model. How many Indians can understand English? 10%, 15%. What about 85% people in India? So who is going to build models? We can translate, but can we build models for Indian languages, for other languages in the world? That's how we said that we'll build multilingual models, because English is available everywhere. A lot of models are there. But basically, building models from scratch is something which I think, as an Indian, we are very, accustomed to having many languages. No other country has this many languages. So we said, like, we should use this, and that's how we started working and building this Hanuman models.
Awesome. Thanks for that context, Dr. Vishnu. Gaurav?
Yeah, no, thanks, Dr. Vishnu. That was it's really amazing to hear about my journey around generative AI, right? So I've been working in the space of AI for more than a decade, and very recently at NVIDIA and Ola, and I realized through the experiences of building the product and scaling the AI product that as you scale, you start to see a lot of failures, right? And that is one of the challenges that the industry faces when they start to deploy technologies, AI technologies. And come Gen AI, right? This problem, Gen AI is magical, right? It can do wonders. Dr. Vishnu is giving some examples there, right there. But come Gen AI, the problem becomes even more challenging, right? So that's where the journey started for me to go more deeper into generative AI and some of the things that we need to basically address the reliability aspects of Gen AI, right? And that's exactly what we do at Raga AI. Right? That has been a fascinating journey for us for past couple of years now.
Yeah, so thanks for that. Amazing. We are very happy to that both these firms, right, are working on Gen AI in India, out of India. So yeah, we are really happy for the paths that led people here. Like a follow-on question for Dr. Vishnu. One thing that our audience, right, like we see, at least from our customers, typically ask us is, which applications today should they be building, right? Where is the technology frontier, right? Technical feasibility when it comes to Gen AI applications. So as both a foundation model builder and also somebody who's building applications, we would love to hear firsthand from you, what is the internal rubric through which you evaluate new applications? Is it worth investing in right now, or maybe something that should be tabled for later?
Yeah. So it's a very interesting question, because I get called by a lot of investors, especially to give my opinion on the investments they're going to do, because everyone says, fear of missing out. We don't want to miss generative AI companies, but like, which are the companies we should invest? So recently somebody asked me, like, I will tell you such a huge contrast. They wanted to invest in a company which is building infrastructure, GPU, cloud, and they wanted to invest in a company which is solving some HR problem using generative AI. So this is in the bottom, that is in the top. So how I see the whole generative AI framework is, there is an infrastructure company, there is a large language models like a platform. On top of that, you build applications and products. The products can be domain specific. The products can be very horizontal, solving, like Raga AI is a problem solving solution which can be used by any domain. But if somebody is solving HR problem, it's a very specific domain. So this is where a lot of applications and products will come in the future, because building a platform, building infrastructure is going to be super expensive and also a big money business. Number of companies will be very, because it will all consolidate. It will become like either 3, 4, 2 companies. But on the application part, especially solving problems, because generative AI is just beginning. We have not cracked. It's not a very evolved technology. It's not like I know everything about generative AI. It's just beginning. So even the foundational model people and even big companies, you know, which are those 3 big companies. I work with virtually every one of them. Even they have not figured out like what are the potential problems, potential solutions for it. So it's just evolving. So there is a huge opportunity there. And I feel that's where even better than like, you know, solving domain specific problems, because domain specific problems, I see somebody solves a very small problem like, you know, automation of HR CV. That will become one feature of Copilot in 2 days. They will just copy that and then say, it's also part of my offering. So they will start, you know, whatever is more people are using them. But these problems, you know, where like, how do you productionize, you know, production is the biggest problem. Out of 100 POCs, only 2, 3 are becoming real products, because there is a big gap between, you know, POCs and real. And that's where the potential problems are also there. Solutions are also there. And people, if especially Indian companies, if we can work on that, it gives a huge opportunity for companies to really scale products. There's a lot of problems, a lot of solutions, a lot of challenges are there. And that's where most of the models are also working, you know, the potential, how do we solve this problem, that problem, hallucination problem, how do we solve the tokenizer problem, how do we solve cost problem? These are 3 big. I think when you showed your deck, that 3 problems, you have really nailed it out. I really like that. 1 slide, 3 big problems.
Right. Yeah. Thanks for that framework, right, Dr. Vishnu. Just a follow-up question on that, right? We know that there's a lot of exciting research happening in the world of like agentic applications, right? And also all new kinds of frameworks that people are building, right? Graphical RAGs and others, right? So as a developer, right, as an application developer at an enterprise, like, is that something that you believe should be embraced by developers today? Like, should they start thinking and like investing in those kind of applications today, or should they stick to traditional RAGs, directly prompting in LLMs and co-pilots, right? How do you assess that as well?
No, agents are the future, because RAG and prompt engineering will be something temporary, but agents will be the real game changers when it comes to how generative AI is going to evolve, because agents is where a lot of use cases will get solved. RAG prompt engineering will solve B2C problems, you know, like I need something, I can ask and then find. But when it comes to real business use cases, I feel like agents are going to be the big game changers. Because for a business use case, you need at least, you know, 3, 4 skills to be coming together, understanding 3, 4 problems, and also bringing data from many things. So RAG and prompt will not solve that problem. Agents is going to solve. But agents is a challenge, because still there is no easy way of building an agent. So it's still an evolving technology. So we are in the intersection where prompt engineering RAG can be done very easily. A lot of people are doing it. It's giving good results. But agents is where when you see the real potential application use of. So we're intersection between there. So if you're a developer, if you can really do something deep work, go for agents. But if you're just a use case, like, you know, if you're in a company which is trying to use generative AI, so RAG and prompt engineering really works. And I also see huge advantage for people who learn prompting, because virtually everyone should learn prompting, you know. Even as a user, if I'm good at prompting, I will get better results, because generative AI is something which is like, the better you prompt it, the more results it gives, especially for big models like ChatGPT or Hanuman. So prompting, I'm even suspecting that engineering schools will start something called prompt engineering as a course or something, or even like, because it's going to be huge. somebody will who can make it simple for people to get a lot of information using right prompts. That's a big game changer. But it's a very small technology. People can easily rig that. But building agents, that's going to be key.
Got it. Thanks for that. Those insights, Dr. Vishnu. Gaurav, the question for you is like you've been in the world of AI testing for a long time. What kind of challenges and concerns do you hear from data science teams across the world trying to build LLM and GenAI applications?
Yeah, no, thanks, Jigar, for that question. I think we are at Raga AI, we are working with customers across the globe, some very large customers in US, Europe, and India, right? And when we work with the data science teams, right, there are some very important problems that they clearly come to the surface, right? Number one is the reliability, right? That is the top of the mind today of every data science teams who are basically different stages of development, trying with the intent of taking LLM based solution to production, right? There is a lot of at stake at times, right? And the teams wants to make sure that they're able to deploy and scale a reliable LLM, right, where the output is consistent and right all the time, right? So I think that's number one. Number two is basically cost, right? As we start to scale, the cost starts to balloon very quickly, and the teams who have already deployed it, or the teams who are thinking of deploying, right, that is becoming extremely important. And the third very important is real-time performance, right? If I'm doing, let's say, an enterprise search or a Q&A, right, if the latency for whatever reason is not real time, is not within the bounds, or the performance is not within real time, then that's a big concern, right? There's some smaller things which are also very important, right? In terms of data security, for example, and privacy, right? Which is also top of the mind. So some of the things, right? So yeah, so these are some of the challenges we see across the board, right? That when we work with data science teams across the globe, yeah.
Thanks for that, Gaurav. With that, we'll just we want to check the pulse of the crowd that we have here. We have a poll designed for our audience. So maybe we can put the poll up. Perfect. So the poll should be visible on your screens now. This is about what is your primary concern when it comes to building and deploying Gen AI applications today, right? So all the dimensions that Gaurav mentioned, whether it is maintaining high accuracy and lower hallucinations, things like data privacy or security, that's option 2. Robustness to adversarial attacks, if you're in a sensitive industry, or high costs and latency impacts. So we would love for our audience to vote on this poll and see where what people are struggling with today, so that we can delve deeper into it during the next part of our discussion as well. Right. Perhaps we can get the results. Collect the results now. There we go. So I think we see a high accuracy and low hallucinations is top of the mind for everyone. Data privacy and security is the second most important thing, not too far down the road. Robustness to adversarial attacks is not probably a big concern at this moment in time for folks, and costs are like a much lower concern at this point. I think so. Performance and security, it seems like the 1 and 2 are top of the mind for folks. So that's great. So that's our next question as well for Dr. Vishnu. We know that you have been building AI applications in the world of healthcare, where actually a highly regulated industry, the bar for quality is really high. So how have you approached, right, your building applications to be trustworthy and safe, right? So we would love to hear your thoughts on that.
Yeah, I expected the first question to be the major concern, because that itself shows, we are still figuring out which models to use for problems. And so that's where high accuracy and hallucination both come. And hallucination is something which I don't think is, the real problem. It's part of generative AI. It's like, a very intelligent person who will not say, I don't know. They will somehow try to answer something, like, so big models are like that. Virtually, they have seen so much that they will find some pattern somewhere, and then they will answer. That's how hallucination comes. So it's part of generative AI. So the bigger the model, the more it has been trained on more tokens. So hallucinations are going to be part and parcel of it. That makes it very difficult to use in applications like healthcare, finance. I can name like 100 domains where it's going to be challenging because the accuracy has to be very, very high. And something hallucinates. It's already we are seeing a lot of companies have faced this problem when they started suddenly using it. So this is going to be a big challenge. So how do we mitigate that is one question. Number one, if you are using an open source model or a publicly available model or something, so never deploy it at a production scale without properly checking for hallucination many times. If there is a hallucination, work on prompts and work on other technical aspects and then reduce it, because it's going to be a killer in the business. Imagine a banking application or something starts giving some wrong answers. That's one part. But technical level, we have figured out few things how we can do it. One thing we have figured out is you don't need to have the biggest model, always best model. That itself is the wrong notion. Models should be like horses for courses. What do you want? More precision. Smaller models always work better because we have seen the numbers. My team keeps doing so much of work and research on like which is the best balance. Is it like smallest model or the biggest model, or a balance? So the balance is somewhere around 3 to 7 billion parameters we have seen for specific domain cases. Also, what goes, see, model is nothing. It's all about the data, what data it's trained. So I work in very cutting edge things like understanding genomics, where data sets are entirely different. You don't get them anywhere, right? Like you can't expect a common model to have been trained on genomics data. So when I train that very specifically on genomics data, then it works very well. But what is the base model which we are going to use? Like, is it a simple language model or it needs to be, something specific for that? So these are the kind of challenges which people will face. So I feel that if you, my simple framework, if you want more precision, use a smaller model which is very well trained with that particular domain data. If you want a very general skill set, like say summarization, all these simple things, any model works. And second important thing is 7 and 70. If you see any open source model, either it is 7 or 70. Why? So 7 is something which can be easily deployed. You don't need much resources. So the cost comes down. And 70 is something where you need GPUs. So if you can, afford GPUs, go for 70, because the model accuracy is better there, but it costs more. But if you can, compromise on that, if you feel it's going to be expensive to do that, a 7 or that models really work. And now we are working more on less than 3 billion parameter models, something like 2.4 something. But still, it's a work in progress. But models will become better and better going forward. So that's the key, right? Like, so if I have to give a framework, if you want accuracy, go for a smaller model strength and specific data. If you're fine with that, generalized applications, go with the bigger model because they work well in those aspects.
Got it. So thanks for that, Dr. Vishnu. Just a follow-up question there. We do see up and coming regulation, right, on AI. in many
Yeah.
domains, right? Whether it is the EU Act or industry specific. So, would love to get your thoughts on that as well. If the kind of frameworks that we have talked about right now, right? Smaller models, right? Robust testing, right? Do you think they like we are still at a point where we can bridge the regulatory gap between what we are building versus what the regulators expect, or there is more work to be done on that front?
See, regulation, when it comes to regulation, there are three major regulations geographically. One is Europe, US, and then India.
Yeah.
Europe is highly regulated. They already have this GDPR and all that. So they're trying to regulate generative AI. And US and India have not officially come up with any policy around generative AI, but still it's a work in progress. But whatever the common laws which were applied before generative AI still applies right now. And they are with data privacy and all that stuff, like which data you can use proprietary data, can use public data, how you are using the data, all that things are there. But see, because it's just beginning, a lot of things have happened and can happen, but later this will fall on our heads once the market matures and the policies come up. So my advice for anyone is to just don't play with data. See that the data you are sourcing, the data you are processing is something which is because that's where the key problems will come later than anything else. From where did you get this data? You'll get sued later. Like you use something which is which has IP of some other company or someone else's copyright. All this is going to be a big problem later. Like once people start understanding how this data is going to be used. Already we are seeing ChatGPT being sued by New York Times and all that folks. So Indian companies can't really afford that. I will tell you one important challenge. Especially for folks who want to deploy these models in US market, there will be indemnification which will be asked by these companies. They will say that, see, we are using your model and we are using your application. If something goes wrong and if you have used something, like, do you want to indemnify later? If someone sues me, who is going to pay it? So that's a big challenge, because big companies have really done like big insurances, and they're saying that, okay, we'll indemnify our products. If something happens, we are going to be responsible for that. But a small company can't do that. So you'll get sued, then it's going to be like huge trouble. So when you're deploying that, see that all the data sources which you have used and all that are perfectly legal. Because that's where I see is going to be a major challenge, because later also these things can come up. Today people might not recognize, but later it can come up. So that everyone has to keep. I think Raga AI also has to look into that and see like from where the data is coming, how they are using that data, whether they're legally they can use that data. That's going to be key challenge.
Got it. Thanks for that foresight, Dr. Vishnu. Gaurav, one more question from my side for you is like, what kind of solutions do you see data science and also software developers adopt, right? In order to address some of the concerns that we have talked about, like reliability, like hallucinations.
Yeah, no, definitely, right. So I think hallucinations and some of the other challenges, for example, reliability challenges in LLMs is a big issue, right? And there have been some approaches, good approaches that has been used, right? So things like looking at context similarity between, let's say, the output and the context that's there, right? I think that's one of the approaches that is taken. LLM as a judge is becoming very popular, right? And LLM as a judge with reasoning is also becoming a very recent, very popular approach to basically figure out if the output is reliable, right? In one sense, I think there's a lot of work, as Dr. Vishnu said, right? Needs to happen to make sure that GenAI LLMs are reliable, and as LLMs are becoming better, right? I think these technologies will also evolve, right? So a lot of exciting work happening in this. Means Raga AI is involving all the best technologies that are out there, right, in our product, right, to ensure issues like hallucinations, some of the other challenges that are out there, right, are detected, diagnosed, and fixed, right, as LLM are scale, right. So yeah, go ahead, please.
Awesome. So thanks, Gaurav, for that. With that, we'll move to a second poll, right, on that topic about how are people trying to address the kind of problems and concerns that we have talked about. Let's get that up. Perfect. So we're talking about quality assurance, right? In many ways. So how are you trying to approach quality assurance with your applications today? So the one option is my AI application is a co-pilot. So that's how I'm structuring my application. I'm less worried about quality assurance because there is a human in the loop for every single inference. Second is I'm relying on foundation model builders like OpenAI, like Hanuman, to actually address these problems for me, right? So the R&D effort is taken up by these foundation model builders. I'm building solutions and QA platforms in-house today because you can't wait, or people looking for third-party products to use off the shelf. So we would love to see, check the pulse of the audience where folks are right now. Perfect. We can get the responses up. Yeah, so no surprises there. Relying on foundation model builders like OpenAI and Hanuman to address all my quality problems, right? That seems like the majority vote. So our next question is obviously from here for you, Dr. Vishnu. Like, how, is that how developers should be thinking about it, right? How would you think about it? Yeah.
No, obviously, the onus is on the foundational models to address quality, but quality doesn't start and end with us. So that's going to be challenged, right? So because foundational models will be never built for any specific use case. They will always be built for some general purpose, which can do a lot of things, but you have to again rework with it and then make it better for your specific application. So nobody is going to build a foundational model which addresses your use case perfectly. That's not going to be how foundational models are built or even thought about. So we are solving, a general purpose problem. Like it's like, Java. Java will not solve your problem. You have to take Java and then build your app. So that's how it's going to be. So when it comes to that quality, we take a lot of effort to do that because a lot of responsibility is also on the foundational models themselves. Because if you see the market itself, why a lot of companies are not building foundational models, because it comes with huge responsibility. Because that's where it begins. So when we started to build foundational models, the first thing people told me was like, it's a huge responsibility, don't take it. It's not easy. But whoever is doing that comes with that feeling that, that we have to address that problem. So we test, like it takes us months of testing to even before we release the model to public. We even say that this is the final model which we have released. We do a lot of testing, but even in spite of all that, when you really try to use it for your specific application, sometimes hallucinations, all this stuff can really come because it's very difficult to predict like what will happen in a specific use case when you start deploying it at a scale. So that's when another layer of quality assurance need to be there, where you test your own model. Because again, when you're rolling out an application, the application's responsibility is on the company which is doing that. So both layers are super important. And obviously market will see that which model is more reliable. Obviously, that's the model they're going to deploy. So if models are not reliable, they don't perform well on the benchmarks. So it's a very open thing. So people know that like this is not the right model for me to use. So people would go there. But still, benchmarks won't suffice. I would say that build another layer of quality assurance on top of it when you are deploying.
Thanks for that, Dr. Vishnu. Gaurav, your thoughts on that, where folks are relying on foundation model builders to address quality problems?
Yeah, I think I just would echo what Dr. Vishnu said, right? Um, uh, so today, in today's world, we see that there is a lot of challenges, right? The foundation models will become better, right? But they will. We see that there are different dimensions of problems, right? As we go to the next generation of foundation models, right? So and that's the reason. That's where we are committed to basically address all the different dimensions of potential failures, right? Even as the technology from the foundation model companies improves, right? Which will happen, right? Of course, right? So that's exactly the thought process is that, right? That we want to ensure that as we scale to production, right? We are able to do that in a reliable, safe, and secure manner, right? Yeah, over time. Yeah.
Perfect. So one more question from my side before we jump into the audience's Q&A. Feel free to put all your questions in the Q&A section of the Zoom session. We'll take those up next. My question is like open-ended. How do we see the next wave of models and applications evolve, right? And as well, and along with it, the need for quality assurance and testing, both from like whether it is multimodal applications, we know that Hanuman is working on it, agentic applications. We hear a lot about AGI as well from OpenAI, but would love to get your thoughts on that front, Dr. Vishnu, Gaurav.
Yeah, AGI is the next frontier, but it's something like, autonomous cars, which has been there since so many years. Since last 10 years, we are speaking about autonomous cars, but still nobody will let you drive a car sitting on the backside. So you have to be there on the steering. AGI is something which is more of a theoretical problem, like how do you even define it? But when it comes to the reality, if you take like what is the AGI real level, like it's level 5. So we are either at 1 or 2. So it will take a long time for generative AI to become AGI. Till then, a lot of improvements will come because currently large language models are good in some aspects, but like they're still way behind humans when it comes to like logic and reasoning and human reasoning, not like artificial intelligence reasoning. So it will really take a lot of time and data to when remotely do what humans can do. So I'll give a small example. My 2-year-old daughter, she has seen one unicorn, which is like a unicorn itself is a imaginary thing, right? So wherever she sees anything remotely looks like unicorn, she identifies it. The model would need 1 billion pictures to even get it right. So that's so far humans have really nailed it. Like, with very little information, very little exposure, we can extrapolate a lot of things. So for a model to do that, I feel like it's going to take at least transformer technology will not do that. Currently, what we're using for LLMs. So that's my that's my view. It can be right, wrong. I'm not a authority on this, but that's how I look at it.
Got it. Thanks. Gaurav, your thoughts as well?
Yeah, no, so I think few dimensions where in the short term or mid term we see, and I think long term is AGI as we are discussing, right? So I think one area where we are seeing a lot of development and potential happening is agentic framework, and Dr. Vishnu also talked about it. I think there is a lot of work happening in that area, which actually will open up a lot of use cases as the technology becomes more mature. Another big area is small language models, right? Means we don't have to run a 500 billion parameter model for something which can be done for 5 billion parameter model. And we are seeing more and more enterprises and customers and users, data science teams are leaning towards that as well, right? I think that's another very interesting basically direction that we are seeing, right? Which will make this technology more accessible, right? Both in terms of accuracy, cost and latency, and of course data privacy aspects as well. Yeah. So these are some of the dimensions we are seeing a lot of exciting developments.
Awesome. So thanks for those thoughts and views. With that, we'll just jump to Q&A from the audience. We have one question asking about how do you think of a security or authentication layer for products built on top of LLMs? In simple terms, let's take a conversational bot for e-commerce company. The response details are very much concerned to the user or customer. How do you handle these in agents? What's the future for authentication or authorization in LLMs? So, Gaurav, you want to take that?
So let me just understand the question correctly, right? So talking about security and authentication, right, on top of LLMs, right? So this is one of the dimensions that that we talked about, is one of the top of the mind for the data science teams, right, as they go from concept to production, right? So it's extremely important that these technologies are the security and authentication aspects are taken care of, right, as LLMs are deployed into production, right? As LLM technologies become more mature, some of these will become part of the foundation models or the small language models through open source or whatever other areas. But I think there is a need today very clearly to have like a firewall, right, which takes care of authentication and security, right? From application perspective, or built on top of LLMs, and that is how we are addressing that, and we are seeing like some of the latest technologies used to address that.
Perfect. Thanks for that. Second question for Dr. Vishnu: how do you define hallucinations? I think that's a
it's a very interesting question, because though it's very commonly used, how do you really define it? Because there is no single line definition. So hallucination can be simply put two things. One, when a model gives factually incorrect information. If you ask for factual information, like, when was Gandhi born, and if it can't properly tell that date of his birth, so it can be factually imperfect hallucination, which is easily testable also. If the model is not trained on that particular aspect, so it can give factually incorrect information. The second thing is it can even give information which doesn't exist. So this is a lot when you ask, especially to cite sources and all that. Models can sometimes even throw up like their own cooked up citations. So these are more challenging, because especially people have really flunked when they used it for purposes like research or citing some sources where the sources themselves were not there. And in many applications like law and all, where people have tried to use LLMs, they face these problems because LLMs can even cite some judgments and laws which don't even exist. So this is a big challenge, because they are like some things which are difficult to even test and understand. So hallucination is something which we have to keep in mind, especially when you are using generative AI reports verbatim. So many people try to just like take that and copy paste in their prompt, and it becomes a challenge. So defining hallucination and understanding what are the different ways of models can hallucinate is super important.
awesome. Thanks for that, Dr. Vishnu. So we have a question from Manoj Kumar on what are the top reasons for slow POC to deployment conversion? What is missing? And which use cases today are heavily deployed in production? Gaurav, you want to take that?
Yeah, I think that's a very important question, right? Means Gen AI and LLMs are very powerful, but what we have seen across, right, data science teams across the world is that there is a lot of effort goes from POC to deployment or production, right? And the intended results at times are not seen, and there are a plethora of reasons, right from the development of LLM pipeline, right, which has many important decision points. Let's say we are building a RAG pipeline, right? Which LLM is the right LLM for the application, right? What kind of context DB we are using, right? What is the depth of the context DB, right? So things like those, what kind of embeddings are being used. All those decisions, if any of those decisions are not done right, it will have a direct impact, adversarial impact on the outcome, right? After the deployment, which will make the process much slower, right? The second part is that, which we talked about, is how do we ensure the aspects of reliability, security, data security, right, and cost latency, right? And if those are not addressed well in a very comprehensive manner, right, most of the enterprises, large, mid, or small, will hesitate to deploy, and we have seen firsthand, right? They do hesitate, right, to deploy. So that's a very important second aspect, right? That should be taken care of as well. Yeah.
Awesome. Thanks, Gaurav. So one more question. Given the trade-off between performance, cost, and quality in LLM applications, what strategy can be employed to strike an optimal balance for different use cases? So I guess, how do you balance these performance and cost concerns across different use cases? Dr. Vishnu, would love to get your thoughts on that.
See, if your POC has to convert into a real, use case where people deploy it, it's all about ROI, return of investment. Whether in the business sense, whether it is reducing your cost or whether it is creating more revenue. So this is how CFOs and CEOs are going to take decisions, because many people try many things, but ultimately these are the ones which will be really deployed by businesses. So now if you have to bring down your cost, so you have to keep the cost of deploying. Like if I'm saving $1 but have to spend $2 on my LLM, they're just not going to fly with your CEO. So you'll strike down that, right? So we have to really keep that in mind. And second thing is a few things like, increasing productivity and all that stuff are there, but difficult to really show tangibly on Excel sheet like this is how it's going to be. Maybe in the future it might come, or else enterprise might go for copilots and try to improve the productivity and all. But real use cases will come from like whether you're reducing cost or like you're increasing the sales or revenue of your company. So for that, best model is which can be deployed in the most economical way, rather than like spending a lot of money for bragging rights that I use generative AI. That won't fly, because your bill is what ultimately matters. So smaller models, more accurate, are going to be the real business to enterprise use cases. So keep watching for the smaller and smaller models. That's where the whole industry is moving. The bigger models will only for copilots and something which will be used on enterprise scale. But when the real stuff is going to be the smaller models, and edge computing will really kill it, because that's where we are also trying to move. If edge computing comes, the cost of compute will become less and less. And readily deployable models which need to be not much worked on, not use training, are going to be another key. We can just do the inference, because inferencing cost is cheapest than anything else you do in large language. Fine tuning also costs more. Other things cost more, but inferencing is cheap compared to these things. But at a scale, even that matters, like how millions of tokens, what is the cost of million tokens? Because million tokens looks big number, but when you really deploy, it's nothing. Because you ask a question that goes into the cost, and your answer goes into cost, right? So it's going to be the key there. So smaller models work better. Yeah.
Got it. Thanks for that. And one last question, Gaurav, for you. We have a question on how should you think about evaluating LLM agents?
Okay, yeah, I think that's the next big thing, right? As Dr. Vishnu was also mentioning, we talked about it, right? So agents are becoming extremely important for to realize complex workflows with the combined with the capability of Gen AI. And basically, the fundamental approach is to look at end-to-end agent testing and individual component testing of the various parts of the agents. We are actually will be announcing something soon on that. We are working on some of those interesting technologies, and I think then we will have a much more deeper discussion on that topic, I guess. Yeah.
Perfect. Awesome. So I think we are close to the end of time. Just wanted to remind our attendees that you can I hope most of your questions we have been able to take. There are a few that I see are open and our team is actually busy answering those. Feel free to shoot us those questions even after this webinar directly to us or to Dr. Vishnu. I think we'll be happy to answer any top of the mind questions from the developer community that we have here. That also I wanted to highlight that we are also at today actually enabling users to get a peek into the Raga AI evaluation product that we're building specifically for LLMs and Gen AI starting today. So I've also pasted the relevant links both through documentation as well as a public sandbox in the chat. So we invite you to actually take a look into the product. Like any feedback, any thoughts that you have, feel free to reach out to us. We'll very much appreciate it. There's also a thriving Slack community. If LLM quality is something that is and cost is something top of the mind as you build your applications, please do join the Raga AI Slack community that you can find on our website to keep you updated on the latest developments on that front. So with that, thanks. We would love to extend our thanks to Dr. Vishnu and Gaurav for spending their precious time with us today. It's great to get your thoughts and framework thinking about the very dynamic world of Gen AI right now, which all of us are trying to keep up with. So thanks again for your time and your and for answering all the questions from our audience. Yeah, with that, so yeah, that's really it. With that, we'll pause on this webinar. But like I said, feel free to reach out to us or Dr. Vishnu with any further questions. Thanks, everyone. Have a great day. Thank you, Dr. Vishnu. Thanks.
Yeah, thanks for calling. It was great talking to all of you. Thank you very much.
Likewise.
Thanks. Bye-bye.